Okay, I guess I'm live. So thanks to everybody for setting up this event, and Ed and Jake and everyone. Uh, I like the thing Ed said about the space palette being something that people conduct an orchestra of visuals and music. I've got the space palette here. It makes use of these the Sensel Morph pads, which are incredibly sensitive pads for finger painting. Um, Interestingly enough, they market it for music, but I think it's actually an amazing thing for visuals. You can see the harder I press, the bigger stuff gets. So all the data is incredibly useful for visuals. So this talk is going to be about my recent experiments. Let me get the chat up here so I see. So my recent developments is, on the software behind the space palette is what I'll be describing, and I've been packaging it so other people can compile it and make use of it. So let me get into it here. So I'll be describing a bit about how the palette software works, something about what I consider events, and some experiments, and I'll be demonstrating it live. So the palette software, it's a collection of pieces that constitute the Space Palette Pro. The original Space Palette was Connect based, using free space and the equivalent of pressure in the morph was depth in the Connect, but very similar. So I've been working on this stuff for 8 years or so, and the target, one of the targets has been as a casual instrument for festivals like Burning Man and so on. So, and simultaneously I use it for performances occasionally, but the main target has been festivals and things. So what I've been doing is making use of APIs to communicate between the pieces of the palette, and these are APIs that use network connections, and there's a lot of flexibility and advantages that makes possible. One thing is that you're not locked into the language that a particular thing is implemented in. I'll talk a bit about the programming languages in a second, but any language can be used to inject things using the APIs, and it also lets me separate the GUI, the graphical interface that's used to control things, and the device input from the morph and other things, separate those things from the engine that's doing both. Actually, there's two engines. One is doing the sounds, and the other is doing the visuals. Sound-wise, I'm using mostly Omnisphere 2 sounds running inside Plug Bedul. And visually, I'm using Resolume, and there's a free-frame plugin. Both of those things, Resolume and Plug Bedul, are controllable by OSC, which is an API, and I've definitely taken advantage of that. So what I'm describing here is work in progress. I'm continually trying new things and learning new things. So the pieces of the Space Palette implementation, there's the one core of it is a real-time engine and API server written in Go. Go is a relatively new programming language that I'm in love with. It's kind of like a new C. It doesn't have a lot of the issues that C++ has. So it's a new take on a C-like programming language, and for me, it's actually made programming fun again. So it has garbage collection, and anyway, lots of features. So I love it. So the core is written in that. The GUI that talks to that core is written in Python currently, which works okay. And then the third piece is a free-frame plugin that runs inside Resolume, and that's where all the graphics get done. Currently, everything I do is Windows only, but one of the reasons for using Go and Python is that they're portable to other platforms. But for the moment, everything I do is Windows only. And one of the things I discovered in this latest experimentation is this pub/sub messaging system called NATS. One great thing is that it's all implemented in Go, but it's just a super simple messaging system. Each message just has a subject and then a body, and you can do whatever you want to with that. Do APIs and everything. It's very simple, but also industrial strength, written by a guy who's been doing pub/sub systems for a long, long time. So I discovered that as part of this. I actually spent probably a good month or two implementing my own messaging system before I discovered NATS. So I was happy to throw away all that and use NATS. And there's clients to NATS for a huge number of programming languages. And so there's the source code link in GitHub. All the source code for all three of the major pieces is all in that repo, although there's no real documentation on how to use it. For the moment, I'm working with people one-on-one. So talking about events, I mean, I could have called this talk, API-driven things. There's not much difference between APIs and events. API is just a way that an event is, transmitted. One type of event is cursor gestures, and the cursors I deal with are three-dimensional cursors. So you've got X, Y, and then the pressure is the third dimension. And you notice every finger has completely independent pressure. You may have heard recently about MPE in the MIDI world, which allows you to have essentially polyphonic, per note expression. I get that for free here when you have three-dimensional cursors. MIDI input is another type of event, and then API interfaces that let you simulate these events. So you don't actually have to have a Sensel morph to generate three-dimensional cursors. You can write a program that generates three-dimensional cursors, and I'll actually show that in a second. As far as the technology for invoking APIs and the network transport, OSC is quite popular and good. The one downside of OSC is that it uses UDP, at least the de facto implementations almost invariably use UDP, and you're not guaranteed that those messages will actually get to the thing you're sending them to. The vast majority of the time it works fine, but I had a case one time where I was sending thousands of OSC messages per second, and even on the same machine they were being dropped, which is perfectly okay in the UDP spec. But if you're using OSC for like cursor information, things where it's okay if a couple messages are dropped, that's cool. If you're using OSC for APIs where it matters, then. But in any case, I mean, OSC works 99.99% of the time. But the other way of doing APIs, the network transport I'm using, is this NATS system. And it is it works both locally on one machine, but also remotely. So I have one server in the cloud that's running a NAT server. And so events and APIs go from my machines into the cloud and then back down to some other machine. So the things you can do with events, responding to events, whoops, where am I? So the cursor events that are getting sent from they're going from this real-time engine in Go into the FreeFrame plugin using OSC. So that's really primary event response. You can send MIDI and generate sprites from that. You can send these events into the cloud, and I get that for free. I should have turned off the phone. I get that for free because I'm using this NATS system. And in terms of manipulating events, you can loop them, you can record them, and so on. You can quantize them in timing. With the space palette, I can turn on looping, and then if your loops get really busy, I have a button that'll filter the events in the existing loop, so you can modify loops on the fly. And one of the more useful things when I'm doing a performance is that I have a keyboard down here, a MIDI keyboard, and so I'm playing a scale. Avon calling. I'm playing a scale, and you can switch different scales using the buttons on this touchscreen here. But I can also change the scales dynamically just by playing chords on this keyboard, and that works really well in a performance. The interesting thing is that the MIDI input from the keyboard is not real time. In fact, I'm purposely kind of avoiding real-time input from the MIDI keyboards and using it more as a control mechanism rather than the live input. And that actually fits well in a cloud-based system because in the network experiments, there's a delay of about 300 milliseconds or so from the time when I press something here and the time the message goes up into the cloud and back down somewhere else to show the results. So as I mentioned, the cloud and this NAT system that's enabled me to do this kind of experiment. So a week or two ago, I ran an experiment where 4 friends each had their own morph scattered around the country. They all ran this palette software and were connected to this Space Palette Pro, and each person was controlling one of the 4 pads, and so their gestures were showing up along with everybody else's, and they also have a GUI that controls all the parameters of their pad. So they have complete control of their visual instrument that they're playing, but they're collaborating jointly with 3 other people. So the basic mechanism worked. Naturally, there's lots of things that I discovered that would make it better. So, but the proof of concept worked quite well. So in addition to leveraging the network, even just locally on one machine, you can leverage APIs, and there's a lot of potential there and a lot of fun that can be had. So I'll be demonstrating each of these things in a second. So you can just write a Python script that generates events that look like you're finger painting. You can take a file like a standard MIDI file and generate sprites from its data, and then you can simulate things, and I'll demonstrate that. That'll be easier to show than explain. Okay, so let's switch to okay, so I've got a some scripts here. Let's see. So here's the simplest script, which just randomly generates 1,000 sprite events. So it's sending a sprite event, giving an X, Y, and Z value for its position and pseudo pressure. So that's the complete Python script. And if I execute it, so now you're not hearing any sounds because it's just sending just doing a sprite thing. It can do a cursor thing, which would be triggering sounds at the same time. And so while it's going there, it's generating 1,000 sprites. I can then go to the GUI, which you see in the upper left of the screen, and I can change, the parameters of the sprites that are being generated. I'm just clicking these different presets, but you can also go in. There are separate presets for sounds, visuals, and effects. Effects are the free frame plugins inside Resolume. So while these sprites are being, spawned by this Python script that's still running, I can go into the visual parameters, and here there's a bunch of parameters. Oh, the Python script stopped. Let me start it again. So I can modify the visual parameters. So currently there's these little squares being generated for the sprites, and I can make have them grow. So you can specify the initial and final sizes, and then the amount of time it takes to go from one to the other, or the shape, and so on. So there's lots of parameters, and the key is that you can manipulate the parameters while things are happening. I can also be doing things interactively at the same time. So the key is to get immediate feedback on making changes. That's and given the network latency of half a second or less, even the remote players who are manipulating their parameters, they can see the effects fairly quickly. So that's a very important aspect. Let's see, what are the other demos here? So here's a similar but different demo. Rather than sending sprite events, it's sending cursor events, which is X, Y, and Z for pressure, and it generates both a down and the up cursor events. You can also do drag events. So what my finger is generating here is a down and then tons of drag events, and then an up event at the end. So you can simulate all those things by writing a program like you see here. So let me run that one. So now it's similar, but now it's simulating actual cursor events like I'm finger painting, and so you're hearing the musical aspects that the space palette does in response to those cursor events. And then I can obviously still change the parameters. And every one of these presets has each preset that I selected there has settings for both the visual things and the musical aspects. Let's see. And then here's the script which there's nothing in the chat. So here's the Python script that takes a MIDI file. So there's a Python package called MIDO, M-I-D-O, which lets you read a MIDI file and process the notes within it. So that's what this script is doing. Here's the loop, and for each note in that MIDI file, it's sending a MIDI event. So it plays the note the way it appeared in the MIDI file, and then down at the bottom, if the message is a note on, it will send a sprite event to do graphics, and the position of that sprite is computed there to make it look like a piano roll. So, which will be so I'm playing this MIDI file, and that script that you just saw is that's what's running. So you can visually, see that it represents the music, but I can change the parameters both using presets or I don't have all the note off things working. So again, while that's running, I can change the shape of things. Let's just start it up again. So I'm just playing with the parameters here. Let's go. Anyway, so you can have a lot of fun just playing with the graphical behaviors. And the visual tab here is just for the sprite kind of thing. The effect tab is for the free frame plugins. So I'll start that up again. And now I can just same sprite generation, but I'm just changing the free frame plugins that Resolume is using. And this is all being enabled because Resolume has fantastic OSC support for controlling the parameters of the free frame plugins. So that wouldn't be possible if Resolume didn't have those APIs. So that's kind of what I'm. Essentially, I've created a free frame plugin, which itself has APIs that let you control the parameters of the sprites that it's generating. So, and that Resolume doesn't know anything about those APIs. But I can talk both to Resolume via OSC, but I can also talk directly to the free frame plugin with OSC. So you can create your own custom APIs. So then the last demo is using KeyKit, which is a language I wrote along many decades ago for MIDI experimentation. And one of the cute little things that I liked doing was generating events from a maze. So here we've got a maze. Let's see. Where am I? Okay, so So I've got I put a ball in this maze. All of the walls of the maze are currently up, and you've got this little ball bouncing around. Every time the ball hits one of the walls, it triggers an event, and in this case, it's sending both MIDI, a MIDI event and a cursor event to Resolume. So you see what that one's triggering. If here I changed it so only 20% of the walls. So now the ball is going around. I can have multiple balls going around. So you could just let this go forever and generate continuously changing stuff. Up here I can control which pad or which color ball I'm using. So if I switch this to B, now the balls I'm sending are simulating cursors on a different pad, so you can see there's different colored things. Okay, so this will make it kind of obvious. I can put 4 different colored, let's see, dun, 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 dun. Okay, so here I've got 4 balls, 1 of each color. Oh, wait a minute. Let me see. There we go. So 4 balls, and they're trapped in the cell of their maze, a 1-cell maze. So you're controlling, essentially, controlling 4 pads at once. I can turn on a mode now here where rather than hitting the wall, it's going to break down the wall. So I'm going to turn it on, and now suddenly these balls are breaking down the walls of the maze, and of course I can, as always, change the settings of what's going on. And so, I mean, there's obviously a lot you could do with this. For example, you could, I can manually break down the walls here. So I can create a pathway for that ball and another pathway here for some other ones. Whoops. Got to turn off breakout mode. And we'll do another one here. Anyway, so it just shows you the kind of fun you can have when you can drive, a visual system or a musical system or a visual music system, using APIs. And so that's what I'm exploring. And so I think that's pretty much all I have. If there's any questions, I'll look in the chat. If you want to see the kind of performances and visuals that this is capable of, if you go to YouTube, Photon Salon, just look for Photon Salon on YouTube, and there's a few videos and there's the latest one I posted shows me playing the palette while it's showing me playing the palette that's generating all the stuff you're seeing and hearing. One of my goals, since I have focused in the past on creating interactive instruments, casual instruments I call them, for Burning Man and other festivals. I mean, one thought is to create an interactive installation, in the cloud, and so that's essentially one application of what I've put together. So I don't see any questions yet. Yeah, so yeah, if GitHub, on GitHub, where was the, there we go. So there's the GitHub repo. The UI actually is kind of an homage to Rob Pike's work with the Blit at Bell Labs. Is there any way you use grid to control MIDI? Yes, I mean that's what it was originally. I mean KeyKit was originally, it is just a MIDI thing. So I'll go back to that. So it was really designed to trigger MIDI. So let me show a little of that. I mean, KeyKit, this list I'm scrolling through here is the list of all the interactive algorithmic music things that I created. So the original version of the of this maze thing was called Joy Balls, and it had lots of options. So you can attach different MIDI files to the walls. You could read a MIDI file and you know, take the first few notes and attach them to one wall, and the next few notes to another wall. And so each wall that you'd be hitting with the balls, you know, would trigger a different MIDI thing. So lots of flexibility just using MIDI. I've given a talk recently on KeyKit for the Rocky Mountain synthesizer group. There's a whole window system and pull-off buttons and things. I actually used it as an experimentation vehicle for user interfaces. So, which works really well when you have things with very deeply nested menus like this. So, for example, here, if I was going to turn on and off breakout a lot, I can just pull off this menu and put it on the screen. So any menu in the system and any button in the system can be pulled off and placed on the screen. So when you have a system with lots of operations, you know, in deeply nested menus, to make them discoverable, but if you're only using a different set at any given time, and so by being able to pull off buttons anywhere in the system, you can create your own menu bars, essentially, you know, on the fly. So here I'll pull off a couple buttons here, and the buttons are just windows like any other button. So I can resize them. Oops. But if I want to lay them out more neatly, I can say take these two buttons and lay them out here. So anyway, so I could go on for a long time on KeyKit, but that's that. Last year, or the year before last, was the first time I brought this to Burning Man, and it was running 24 hours a day. One of the problems with the original Space Palette using the Kinect is the Kinect doesn't work in sunlight, so it would only work at night. since it was outdoors. But the SensoMorph works in any situation. So again, I can't rave enough, and this is the right crowd to rave about the SensoMorph to, because it really, the potential for finger painting on this thing, it's like it's just a perfectly well suited to finger painting, visuals. The pressure, the response, it has a wonderful API that lets you get access to the raw data. And if anybody needs any help or making use of a SensoMorph, and got code that converts the SensoMorph data into OSC. So if anybody needs any help with a morph, please contact me. And and there's my contact information at the bottom. So, okay, well, if no other questions, Jake can switch to something else.